Sarta bostu likhilo relation between here related kisman problem hai relation between refractive index and wavelength of light for a pair of medium দুটা particular medium karone ami eta relation liabo lage you are asked to find a relation between refractive index and wavelength uliabo lage for a particular pair of medium sabhage khunilo etu important suppose this is the interface nam didilo xy which is separating two medium etu medium or nam didisu medium 1 etu medium or nam didisu medium 2 consider this medium is rarer and this medium is denser I am just considering refractive index of this medium is mu1 refractive index of this medium is mu2 velocity of light in this medium is v1 velocity of light in this medium same or different which is more which velocity is more v1 is more no v2 is more v1 because velocity of light in rarer medium is always more than in denser medium so here v1 is greater than v2 okay etia moi eta light source etu normal di dilu aru eta light source le lelu this is a source of light so from which we take an incident ray now any light has got wavelength and frequency any light has got key wavelength as well as key frequency etia eta kotha more rakhibo laibo when light comes from one medium suppose etu enaka aihol dei because it is coming from rarer to denser it is moving closer to the normal ek hol what ray is this incident ray what ray is this refracted ray clear hol a ray to wavelength suppose moi nam di dilu lambda 1 incident ray to wavelength kiman lambda 1 incident ray to frequency nu okay so refracted wave to frequency ki hobo formula ki asile velocity is what is it light is actually what electromagnetic wave any wave the velocity of any wave has a particular equation what is it v is equal to frequency into the wavelength la mod pahoijo ki asile velocity of any wave either it be mechanical wave either it be electromagnetic wave its velocity is always represented by this formula it is the product of wavelength and frequency and wavelength hol etia mod rakibi jetia light eta medium ba belag medium khumai ta frequency ketio change nohoy ki change nohoy frequency that you have to always remember whenever light enters from one medium to another medium its frequency always remain same tamane yat jodi frequency new yato frequency kiman hobo new but what will change because velocity changes this is constant which should change wavelength must change buji paisane why because when light enters from one medium to another medium velocity will change frequency will never change so what should change wavelength must change kotike a refracted wave to wavelength same thakibo na different hoy jabo same na different ki nam dim lambda 2 are etia a kitar major relation lebo lage a kitar major akode akilo enaka akilo direct khali ki mod rakhibo laibo so what point you should remember when light travels from one medium to another medium its frequency is always constant. Always constant. Its frequency is always constant. Always constant, but its velocity and key wavelength changes. Velocity and wavelength changes. যেতিয়া light পানীৰ পৰা suppose glassত সোমালে ক'বা ক'লে সোমাইছে পানীৰ পৰা glassত কি চেঞ্জ হ'ব wavelength চেঞ্জ হ'ব আৰু কি চেঞ্জ হ'ব speed চেঞ্জ হ'ব কি চেঞ্জ নহয় frequency চেঞ্জ হ'ব so এইটো frequency always constant. It's always constant, but its velocity changes. Okay, Rakilo. এতিয়া মই এনেকৈ পঢ়াই আছোঁ দেই নোটছত দিয়া নাই আৰু যিখিনি দিম এনেকৈ লিখি দিম আৰু এতিয়া এই পইণ্টত স্নেলছ ল এপ্লাই কৰি দিম সাপোজ দ্য পইণ্ট ইজ পি এট দিছ পইণ্ট ইউ এপ্লাই স্নেলছ ল সৰি স্নেলছ ল নহয় এনে ৰিফ্ৰেক্টিভ ইণ্ডেক্সৰ এটা ফৰ্মুলা আছিলে আমি এইটো লিখিব পাৰোঁ মনত আছেনে ক'ব পাৰিবি কি মিডিয়ামলৈ আহিছে second medium light is traveling to what medium second medium coming from what medium first medium আমি কেনেকৈ লিখিম refractive index of 2 with respect to 1 এটা ফৰ্মুলা আছে কি v1 by last classত আছিলে v1 by v1 to কি velocity of light in first medium divided by velocity of light in second medium so divided by v2 okay this is equal to velocity means product of wavelength and frequency first medium what frequency kiman nu wavelength kiman lambda 1 so enake likhi lo lambda 1 nu divided by in the second medium wavelength is lambda 2 frequency is same nu so frequency cancel thaki gol lambda 1 by lambda 2 now this equation can be also written as mod asile refractive index of 2 with respect to 1 next class joa class this formula is equal to mu 2 by mu 1 that was explained in the last class so lambda 1 by lambda 2 this is the formula so this is the relation between refractive index by absolute refractive index for a pair of medium with respect to its wavelength of light এতিয়া অকমান নিউমেৰিকেলছ কৰি লওঁ দুটামান so take the problem a film of oil of refractive index a film of oil of refractive index 1.20 lies on water of refractive index 1.33 full stop the ray of light is incident at 30 degree The ray of light is incident at 30 degree in the water. In the water on the oil-water boundary. On the oil-water boundary. Full stop. Calculate the angle of refraction. Calculate the angle of refraction in oil. In oil. So, মই প্ৰথমতে ডায়াগ্ৰাম এটা বনাই লৈছো. This is the interface, নাম দি দিছো XY, which separates two medium. One medium is oil. Oil to ক'ত আছে? পানীৰ ওপৰত. Suppose this is oil. This medium is oil. This is oil which is lying over water. This is water. Water is water. Okay. So water mu W. Water refractive index is 1.33. আৰু যেটো oil লৈছে তাৰ refractive index দিছে mu oil mu বুলি দিছো mu liquid দিলে হ'ব mu L means mu liquid is equal to 1.20 ds. Okay, so this is the oil which is just floating or lying over water. এতিয়া কি কৈছে a ray of light is incident at 30 degree. ইয়াত মই normal draw কৰিলো. A ray of light is incident at 30 degree in the water. কোনটো মিডিয়ামত ইনসিডেন্ট কৰিছে? Water. তাৰমানে এনেকে 8. The angle of incidence is 30 degree. Okay? So, সুধিছে, what is the angle of refraction in oil? Now tell me, here which medium is denser and which is rarer? What about? Oil is more denser. Why more denser? Your refractive index yatke besi. Refractive index jimane besi hoy, that medium is more denser in comparison to the other medium. So light is going from denser to rarer. It will bend. No, light is going from what medium to what medium? From denser medium to rare medium. Denser पर rare लेके चलना है. Denser पर rare लेके लिखी है. It deviates away from the normal. So if it is, right? तो है ना? ये तो की medium? Denser. Which is more denser? Water is more denser. Why? The refractive index of water is 1.3. The refractive index of the liquid is only 1.2. So this is more denser. It's a denser medium. It's a key medium, rarer medium. Light is traveling from denser medium to rare medium. Okay? So it will deviate away from the normal. Suppose the angle of refraction is R. R2 level. You are asked to find this value of R. Key koim direct key law use kori ho jabu. Snell's law. Directly apply Snell's law. Therefore, by Snell's law. You directly apply Snell's law. Tell me, water to oil. So what you have to write? Snell's law will be refractive index of oil. Oil means liquid with respect to water. It will be equal to sin I by sin R. So by using this formula, you can write refractive index of absolute refractive index of liquid divided by absolute refractive index of water is equal to sin I. Sin I is sin 30 divided by sin R. Absolute refractive index of liquid is given as 1.20 and that of water is given as 1.33, which will be equal to sin 30. 1/2 sin R. 1/2 sin R. Therefore, sin R sin R will be equal to 2 into 1.33 divided by 1.20. No. 1.33 divided by 2 into 1.20. So this is equal to 1.33 divided by 2.40. 1.33 divided by 2.40. 1.33 divided by 2.40 is equal to 0.5541. Therefore, R will be equal to sine inverse 0.5541. So either using log table or calculator, you can find out this value. Sine inverse of this mass will be something kiman hobo 33 man hobo niki approximately 30 ke bhalke sai lobi 33 degree man hobo lage. So yet ki more rakibo lagbo eta ektu ekdom sobe more rakibi je jetia light jitu medium pa jitu medium mole jay. Okay, here it is going from water to oil. So what you have to write? Refractive index of oil or liquid with respect to water. Jitu le jay hetu talot ar jitu pa ahe hetu upor. Etu ekdom pura matha khumoi lo. Ulta hoy gole answer to wrong hoy jay. Okay, so ekdom matha tu sthir kori pele onko bilak koribo lage. So take another one. A light of wavelength 6,000 Armstrong. On a light of wavelength 6,000 Armstrong. 6,000 Armstrong in air enters a medium of refractive index 1.5. Enters a medium of refractive index 1.5. Full stop. What will be the frequency? What will be the frequency and wavelength of light in that medium? What will be the frequency and wavelength of light in that medium? It is a whole problem. So in the question it is given that light enters from air medium to another medium. Suppose this is air medium, this is another medium. It is medium, medium. So this is the normal. So light is entering from air to medium. So eku dia nai enekai goise boli dhorisu. It is not said which is denser or which is rarer. Suppose I am considering this as denser and this as rarer. It is rarer hoy air medium. So definitely this medium is more denser than this. So light is coming from rarer medium to denser medium. It will bend close to the normal. It is jitu light incident korise hey tar wavelength, the light which is incident is having a wavelength of 6,000 Armstrong. Now the question is, what is the frequency and wavelength in the medium? A light to refracted light to ki ki uliabo dise wavelength aro frequency. What will remain same? Frequency. Yaar jodi frequency new, yaar frequency kiman new. Ekana moi prothomte ki korim? Ei light to frequency ulialam. Light to ki ulialam? Frequency. Now tell me, what is the velocity of light in this medium? Air medium. Air medium or velocity of light ki hoy? C my velocity of 3 into 10 to the power 8 meter per second. So which relation you have to use? Velocity is equal to wavelength into frequency. So first of all you find out frequency. Frequency equals C by lambda. C is given 3 into 10 to the power 8. Lambda 6,000 Armstrong. Armstrong mane into 10 to the power minus 10. So if you solve it, what you will get? 3 into 10 to the power 8 divided by 6 into 10 to the power minus 7. Etu bole gusi gole kiman hobo? 1 by 2 into 10 to the power bole gusi gole minus 8 plus 15 or 0.5 into 10 to the power 15. That I will did you 5 into 10 to the power 14 hertz is the frequency of the which ray? Incident ray. Eta ki likhibo laibo? কি লিখিব লাগিব since the frequency of light traveling to any medium is always constant. Since the frequency of light traveling to any medium is always constant, therefore frequency in the other medium a medium to kiman hobo same, so nu is also equal to same, so 5 into 10 to the power 14 hertz is the first answer. কিন্তু কি চেঞ্জ হ'ব wavelength হয়নে wavelength চেঞ্জ হ'ব সেইকাৰণে এইটোৰ নাম দি দে lambda dash, the wavelength will change. So to find that wavelength এটা formula দিছিলো এইটো formula, you can use this formula, so you can use this formula, therefore by relation, what relation, mu2 by mu1 is equal to এটা খালি এটা কথা lambda 1 by lambda 2 এইটো formula use কৰিম ন so use this formula, এইটো তাৰমানে mu1 এইটো mu2 যদি ধৰো, so কি হ'ব mu2 কি refractive index of the other medium দিছে নেকি এইটো 1.5, so কি লিখিব লাগিব 1.5 divided by mu1 is the refractive index of air. How much is the refractive index of air? 1. It is the lowest. Refractive index of air is always lowest, so ইয়াত 1 লিখিলে হ'ব 1 is equal to lambda 1 to কোনটো এইটো হ'ল এইটো কি নাম mu1 lambda 1 mu2, so lambda 1 is how much 6000 right, divide by lambda 2, no উল্টা হৈছে নেকি ঠিক আছে inversely proportion হৈ আছে, therefore lambda 2 will be equal to 6000 by 1.5, 6000 Armstrong নহয় জানো Armstrong হলে কি হ'ব into 10 to the power minus 10, so to calculation for 6000 divided by 1.5 4000 into 10 to the power minus 10, তাৰমানে 4000 Armstrong is the answer. Clear হৈছে নে কি মনত ৰাখিব লাগিব, when light travels from one medium to any other medium, frequency will always remain same, but the wavelength will change, also the velocity will change. There is a question given in the textbook. Eta textbook or problem eta korsu. Take the question. A tank TNK tank is filled with water. A tank is filled with water to a height of 12.5 centimeter. To a height of 12.5 centimeter. Full stop. The apparent depth of a needle lying at the bottom of the tank is measured by a microscope. At the bottom of the tank is measured by a microscope to be 9.4 centimeter. To be 9.4 centimeter. What is the refractive index of water? To be 9.4 centimeter. What is the refractive index of water? If water is replaced, by a liquid of refractive index 1.63 up to the same height, comma, up to the same height, by what distance would the microscope have to be moved to focus on the needle again. To focus on the needle again. So, in the question it is given that there is a tank. A container. Jot ki ase boli koise water, filled with water. Etu level olike water ase boli dhor. Water. To a height of 12.5 centimeter. Water to height kiman koise 12.5 centimeter. Okay? The apparent depth of a needle. Down here jodi eta needle ase, etu eta needle. Eta upor pa saute. Prothom kotha ko, needle to kot dekha pam. If you view the needle from the top, okay, you will see the needle here or below or upward. Why? The light ray is traveling from denser to rare medium. So light to enake he jabo. Otike yat kobar dekha pam. Image to yat dekha pam. It is suppose etu nam disu O dash. It koise the apparent depth of the needle lying at the bottom of the tank is measured by a microscope to be 9.4 centimeter. With the help of the microscope, this image has been seen at a depth of how much? At the apparent depth of kiman dise 9.4 centimeter depth of a needle to dekha paise with the help of a what? Microscope. Okay, when the tank is filled with water. Okay, next question to koise or out of this next ako ki koise, if the same tank is filled with another liquid, belakata liquid bhorai dise. Okay, belakata liquid bhorai dise to same height mane water kiman height liki asile 12.5. So liquid is also 12.5 centimeter. Ane aru he liquid to ki di ase refractive index how much? The refractive index of this liquid is L is how much? 1.63. aru yar kiman dise water to uliabo lage neki so etu uliabo lage so first etu koilo. So first question is what is the refractive index of water? Kuntu formula use korim? Ki medium of ki medium ole goise yat ki medium air medium formula to hoy na light kenge jabo etu medium of etu medium ole jabo. So ki koisil formula to mu jitu medium of jay tar refractive index kota hai numerator. So yat ki lage mu water. Going to what medium? Air. So mu A is equal to real depth by apparent depth. এই ফৰ্মুলাটো তেনেকৈ মনত ৰাখিবি তেতিয়া সুবিধা হয় কৰিবলৈ so mu water ওলাই যাব therefore mu water refractive index of water will be equal to d by d dash into mu A. D is how much? D is real depth 12.5, apparent depth 9.4 into refractive index of water air is always 1. So 12.5 divided by 9.4 1.32 like 1.32 asal 33 hoy at approximately 1.32. So this is the refractive index of water which is found in the first part. In the second part to this there is another part in the question. Now the question is what? The whole tank is now filled with another liquid whose refractive index is 1.6. Okay, needle to yate ase kintu upor pa saute needle to ma code dekha pam etu level to dekha pam ne tatke upor dekha pam ne tolot dekha pam agote hetu koilo code dekha pam ina eta formula disilu refractive index of a liquid is always equal to with respect to air is always equal to real depth by apparent depth ane ei duta case what depth is same real depth you have to 12.5 you have to 12.5 real depth is same so this is constant so what refractive index is inversely proportional to key apparent depth I mean more is the refractive index less is the apparent depth less is the apparent depth ko here refractive index kiman paisu 1.32 a liquid to refractive index kiman dise 1.6 here refractive index yatke besi tamane apparent depth kom ne besi kom mane etu level dekha pam ne ya tolot ne upor hai apparent depth koba measure hoy apparent depth surface of khoday measure hoy হয়নে surface of measure hole apparent depth to kom paisu kom poa mane ki e yat thakibo ne yatke upor thakibo upor thak ei khini mat thakibo ei ha yat thakibo yat etu o etu yat o dash so when this tank is filled with this liquid of refractive index 1.6 which is slightly more than water the image of the needle will be shifted more upward হয়নে সো এবাৰ মাইক্ৰোস্কোপটো কোড ফোকাস কৰিব লাগিব এতিয়া লিখে ইয়াত মাইক্ৰোস্কোপটো ইয়াত ফোকাস হৈ আছে এবাৰ এই মাইক্ৰোস্কোপটো কোড ফোকাস কৰিব লাগিব ইয়াত হয়নে মাইক্ৰোস্কোপটো নাই ফোকাস কৰি দিছে সো the microscope has to be moved up and moved down উপৰ পৰা চাওতে আমি মাইক্ৰোস্কোপ লৈ পেলাই এই পইণ্টটো চাই আছো হয় এটা ট্ৰেভেলিং মাইক্ৰোস্কোপ বুলি কয় সো with the help of the microscope it is now focused here biology lab microscope চাইছিলে নাই তললৈ নিব পাৰি the microscope can be slided down also it can be slided up এতিয়া microscope to ইয়াত ফোকাস হৈ আছে এটো পইণ্টত ফোকাস হৈ আছে কিমান ডিসটেন্সত ফোকাস হৈ আছে এটো 9.4 ফোকাস হৈ আছে হল এটা এই ইমেজটো চাবৰ কাৰণে মাইক্ৰোস্কোপটো মই ওপৰলৈ নিব লাগিব নে তললৈ নিব লাগিব ওপৰলৈ নিব লাগিব অলৰেডি ইয়াত ফোকাস হৈ আছে সো মই ইয়াক চাবলৈ হলে অলপ ওপৰলৈ আনিব লাগিব সো কিমান ওপৰলৈ আনিব লাগিব ইমানখিনি আনিব লাগিব হয়নে ইমানখিনি আনিব লাগিব তাৰ আগতে কি আনি উলিয়াব লাগিব এইটো উলিয়া এইটো ডি ডেছটো উলিয়া how will you find d dash second case when the tank is filled with another liquid when the tank is filled with another liquid jeta belag eta liquid bhorai dilu etia kwa formula to ki likhim ei formula to mu tell me what about Mute, upward. Light is going from what medium to what medium? Light is going from what medium to what medium? From liquid medium to air medium. So কি লিখিম? উপৰত mu L, তলত mu A is equal to real depth by apparent depth. Okay, so mu L দিয়া আছে, mu L is 1.63. Refractive index of air is always 1 is equal to real depth is দিয়া আছে 12.5 d dash. D dash to ওলাই যাব. Therefore d dash will be equal to 12.5 divided by 1.63. 12.5 divided by 1.63, which is equal to 7.66 centimeter. That meaning to key. That meaning to key. A liquid to apparent depth. কিমান পাই গলো? কিমান পাই গলো? 7.66. এইখিনি পাই কিনে 7.66. এইখিনি কিমান হ'ব? কোন? এইটো লিয়াব দিছে। ইয়াৰ পৰা ইয়ালে মাইক্ৰস্কোপটো মুভ কৰিব লাগিব। ওকে, সো কি পা কি মাইনাস কৰিব লাগিব? 9.4, এইখিনি পাই 9.4 হয়নে? 9.4 minus 7.66. Therefore the microscope has to be moved up through a distance. Through a distance is equal to minus 9.4 minus 7.66. 9.4 minus 7.66. 1.47. 1.47. This is the NCERT textbook problem. So sometime it may be asked.